All right, friends, breezing through our work today. This is our classwork 8.2, page 529, 1 through 19, 23 through 39 odd. Sorry I didn't give you more. Hope you can enjoy what I did. I'm just going to do two sample problems. This whole 1 through 19 is exactly like the practice you did for the homework, so you should be able to watch the previous videos for help on that. And then out of this section, there's just two problems that I would like to point out. 39 is a lot like the homework, but we'll just work through one more together just for practice. 29 might be a little confusing, and so that's why I wanted to make sure I did that one with you. Because 29, it doesn't give you the picture of a triangle. It asks you to find the sine of 30. But it asks you to use, it says use special right triangles to write each trigonometric ratio. And you might be like, what? Special right triangles? What's that? We did that before Christmas. So let's remind ourselves what a special right triangle is. If you remember, we had two. There was there was a 45, 45, 90 triangle. And we learned that the legs are congruent and the same length at x, and that the hypotenuse was x square root 2. And we kind of learned that was a shortcut, that if you knew one side, you could immediately know the other leg, and you could immediately know the hypotenuse without much difficulty, right off the top of your head. And then we learned, I'm going to draw this one bigger because this is the one we're actually going to be using. We learned that there is a 60, 30, 90 right triangle. Notice the 60 is down here at next to the shorter leg. This is next to the longer leg, the 30. And we learned that the shorter leg, if that was x, then the hypotenuse was 2x, twice as long, and that the long leg here was x square root 3. So when they ask you to solve a trig ratio using a special right triangle, they're talking about either of these two triangles. In this case, sine of 30, this is the only one with 30, so they must be talking about this triangle. And what I want to point out is each of these, knowing these ratios here, basically give you the lengths they're asking for. And what I mean by that is, for the 30, 60, 90, basically ignore the x's. If I were to scribble out the x's, then I have the lengths here, 2, root 3, and there was one x here, so wherever there's an x, I would think of that as 1. Okay, just like over here, I would think of this as 1, 1, and square root 2. So now you've got, just like all the other problems you've been doing, you've got a triangle with 3 dimensions, and they're just asking you for the correct ratio. So if they're asking for sine of 30, well, that means this is my reference angle, because you always want to know your reference angle. So I'm up here at 30, and if you've been doing your chant, SOHCAHTOA, SOHCAHTOA, one more time, SOHCAHTOA. So for sine, that is opposite over hypotenuse. So, S-O-H. So I'm going to go here and go, so what side is opposite of this 30-degree angle? The 1. So that means this is equal to 1 over, what is the hypotenuse? 2. So 1 over 2. So the sine of 30 degrees is 1 over 2, or 1/2. And that is what they're looking for in this particular problem. Something to show you quickly. Okay, you slow that down, find my password. Okay, just wanted to point out, if I take sine of 30 degrees, look what it is. It is 0.5, or 1/2. So just to kind of begin to reinforce, that's what we are calculating, that in a right triangle, each angle measurement has a fixed ratio of 1 over 2. We use the actual special triangle to find that. That's what your calculator is doing when you hit something like, sine of 30. It's calculating these ratios that exist in real triangles. Anyway, ignore that if that confuses you. The key thing is, when they say solve these using special right triangles, they're talking to either 45, you would use this triangle, 30 or 60, you would use this triangle. If they asked for, like, say, the cosine of 60, well, then you would go here. This is just a bonus problem. You're welcome, for free. If I said cosine of 60 degrees, I would go to my 60 degrees, ka. Cosine is ka. Adjacent, this is adjacent, not the hypotenuse, adjacent. So cosine of 60 would be 1 over hypotenuse 2. Oh, cosine of 60 is also 1/2. And you could do that for any of these. Tangent of 60 degrees. would be, I'd be 60. TOA, opposite over adjacent. TOA. So tangent of 60 degrees is the square root of 3 over 1, or which is just the square root of 3. Okay, so again, they're referencing these angles, but again, for this particular problem, sine of 30, opposite over hypotenuse, 1 over 2. Okay, then question 39 is your bread and butter typical trig problem. Once again, they've given us a right triangle, they've given us an angle, they've given us a one distance, and they've asked us for GH, this distance. They want the hypotenuse. To me, that would just be side J. So we are looking for this side here. So again, first step, which ratio do I want to use? SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Well, I have from 34, I have the hypotenuse. So that means I don't want to use tangent, because tangent does not use the hypotenuse. And I have the opposite. So opposite, hypotenuse, that would be SO, or sine. So we're going to use sine in this case. So sine, plug in my degrees, because the degrees always go next to the trig ratio. Sine of 34 degrees equals the opposite, 11, over my hypotenuse, my variable, my j. Okay, so now I've got it all set up, and I need to solve for j. So how do I get j by itself? Once you learn how to do this, you can immediately know what to do, but I'll work through it slowly so you can see why it works that way. We need to get j by itself, but j's in the denominator. So how do I move it over? I'm going to multiply both sides by j. Just like in the previous one problem we did in another video, I multiplied by 4. J will cancel out on this side, and that will leave me with j times sine of 34 equals 11. So that's good. I got the 11 by itself, but I still have j here. So j times this equals 11. How do I get j alone? Well, now I would divide by sine of 34. Both sides. Sine. Remember, sine of 34 is a number. I'm leaving it like this until I decide to solve it and plug it into my calculator. It's going to be a nice, big, ugly, irrational number. So again, this cancels out. And so now j is by itself. So j, the side I'm trying to find, is equal to this fraction, 11, divided by sine 34. If I didn't have a calculator, this could be my final answer. Sometimes you'll see that. And so we're going to plug this into our calculator and figure out what j approximately is. This is what it is exactly. J is approximately, let's find out. Notice, though, what I did here before we get the answer, because you can do this much faster than I just did this. When you have this problem and you don't know what's in the denominator, all I did was switch the j in this. It's 11 divided by this. So whatever this top number is, divide it by the trig ratio, and you'll have this missing variable. If that shortcut doesn't make sense, just work through it algebraically like we did on this problem. All right, so let's find out what 11 divided by sine of 34 is. Here's our calculator. Notice, I don't know which calculator you're using. When you first open a calculator, it usually looks like this. Then there's usually a feature to go to a more scientific calculator where you're going to find the actual trig ratios. So we need to do 11 divided by, now here's an important point. I want to make sure this gets calculated, whatever this number is, before it divides by 11. So I'm going to put in parentheses, divided by sine of 34. I'll close my parentheses. So 11 divided by sine of 34 equals 19.67, rounding to the nearest hundredth. And we're golden. We're good. That's what the book says, and the book is always right. Not, but sounds right. 19.67. Don't be naked. Okay, scandalous. Let's get some feet on there, because this was a distance in feet. It does make sense. It's a good answer because you got a leg at 11 feet. The hypotenuse has to be bigger. 19 seems like a reasonable answer, just short of 20 or close to 20. So J or GJ, GH, J or GH is 19.67 feet. All right, good times, good times. So those are just some sample problems from today's classwork.